Hello everyone, today we're going to be talking about some topics dealing with probability. We're going to be talking about the fundamental counting principle, or FCP, permutations and combinations. Now, particularly the permutations and combinations, kind of similar, but there are definitely distinct differences. So I sort of wrote out ways that you can distinguish based on what you're being asked to do, given some sort of generic example, and then how you compute your answer. So if we're using the fundamental counting principle, you're going to be choosing from multiple categories to create one overall result. So say you were making a sandwich, and you're going to use one type of bread, one type of meat, one type of cheese, one type of condiment, whatever. That's an example of fundamental counting. So you're going to take your number of choices for your bread, multiply by your number of choices for your meat, multiply by your number of choices for cheese, and so forth. Permutations, you are selecting groups of something, but the order of which does matter. So say you are selecting a class president, vice president, and secretary from a group of students. If I was just selecting 3 students, their order would matter because one person is going to have a particular role compared to another. We use our calculator for these, just like the other ones, but you're going to get much bigger numbers typically. You're going to pick the number that you're choosing from, so you're going to type that in first. Then I'll show you in a second, but you'll hit math, scroll over to probability, and then choose the NPR function, and then choose the number of positions that you're actually choosing. Combination, you're also selecting groups, but your order does not matter. So, I'm just selecting a group of 3 people from our group of students. For this, very similar, except instead of choosing NPR, you're going to choose NCR. And like I said, I'll show you how to do that in the calculator in just a moment. Because the processes for these are so different, just make sure that you identify for yourself which situation you're going on. So here I'm picking 7 books from a stack of 32. Order does not matter. How many groups of 7 books can I choose? So this is a combination. So in my calculator, I'm going to type in 32, since that's what I'm choosing from, NCR, and then 7. So in the calculator, once you turn it on, we've got 32. Go to the math menu, scroll over to probability, and choose option 3. We're saying that we're choosing 7 things, or combining into groups of 7, and there are 3,365,856 possibilities. Seems like a lot, but, well, you're choosing from 32, your order does not matter, and you're picking groups of 7, so it should be a fairly big number. Teachers holding tryouts for a school play. There are 15 students trying out for 7 parts in the play. There's no restriction on necessarily who can play which part, but obviously, someone being cast for role A versus role B would create a different type of play, so this is going to be a permutation. In how many ways can the teacher select the students? So I'm going to do 15, permutate 7. So order does matter. 15, math, probability, NPR, get an even bigger number. And part of that is because the order does matter. So each slightly different combination does give me a different answer. So that gives me let's look at another situation. So we're looking at suits. There are 3 different types of suit jackets, 6 different types of shirts, 8 different types of ties, 4 different pairs of pants, and usually when you would wear a suit, you would wear one of each of those, and presuming they all match together, we are taking our number of choices and multiplying them. So 3 jackets, 6 shirts, 8 ties, 4 different pairs of pants. When we multiply all those together, we get 500 and 76. So presuming all of them go together, we have 576 different possibilities. So we just multiply all of our choices. Another fundamental counting principle, just like the one above. So baseball managers determining the batting order for a team. Team has 9 players, but the manager definitely wants the pitcher to bat last. So I like for these to just draw out 9 blanks to kind of help see the possibilities. Pitcher definitely is going to go last, so there's one person that's the pitcher, presumably. And, well, so how many people are left to choose first? Well, there was 9 players. Pitcher's definitely going last, so there's 8 people left. Then there's 7 people left to choose from. Then there's 6 people left to choose from. Then there's 5. You probably get the idea. So I need to multiply all these together, and that gives me a number of possibilities of 40,320 when you just type it in and multiply them all in your calculator. So if the only strategy was the pitcher bats last, there are 40,320 different ways that everyone else can bat. And another version of a fundamental counting principle problem. We are, despite the word combinations, taking 3 digits followed by 4 letters, and we're not repeating any of the choices. So I've got 3 digits followed by 4 letters. So number of possibilities for the first digit, I've got digits 0 through 9, so there are 10 choices. Yes, 0 is a digit. Don't forget about that one. It's typically the one that students forget about. And then if I cannot repeat, there are 9 choices for the next number and 8 choices for the next number. Then I have 4 letters. There are 26 letters in the alphabet, so there are 26 choices for the first, 25 for the second, 24 for the third, 23 for the fourth. Some people also kind of mix up how many letters there are in the alphabet, thinking there's 24. Sometimes they have to count them, but there are indeed 26. So if I take all those numbers and multiply them, I get a fairly large number. Feel free to do it on your own calculator if you don't believe me. But I get 258,336,000 different ways that I can combine 3 digits followed by 4 letters if I can't have them repeat. If I could have them repeat, I'd have 10, 10, 10, 26, 26, 26, 26. So it all depends on whether or not you can repeat. So those are some examples. We'll look at this a little bit more in class, and I'll see you then.